me, Sofia Valdez, and Andrew Trinidad. So for some background information, on August 3rd, 2017, an automobile accident occurred at the intersection of Newton Boulevard, Metric Drive, and Jewell, Texas, between a compact car driven by Dr. Catherine and a tractor trailer driven by Dr. Merle. At this intersection, the truck driver had a flashing yellow light while the car driver had a flashing red light. Neither driver claims responsibility for the accident. Dr. Merle claims to have been braking before the collision and that Dr. Caffrey did not stop at the flashing light. Dr. Caffrey claims to have made a full stop at the light before entering the intersection, and that Dr. Merle did not slow down prior to the collision. The force required to drag a 130 Newton car tire across the pavement at a constant velocity is 100 newtons. Specifications from the truck's manufacturer claim that for technical reasons, the effective coefficient of friction for the truck tires is only 70% that of the car. The car skated a distance of 8.27 meters before stopping, while the truck skated 11 meters before stopping. The weight of the car is 13,600 newtons, and the weight of the truck is 69,700 newtons. The pre-crash angle between the velocities of the truck and the car was 90 degrees. The truck driver claims to have been braking in anticipation of the collision at only 6.7 meters a second. Police measurements show the distance from the car and the traffic light to the collision was 13 meters. Ford Motor Company Corporation specifications indicate the maximum acceleration of a comparably loaded Ford Escort is about 3 meters a second. This is a diagram of the collision. So for equations used for calculations, we have Newton's second law of mass, force equals mass times acceleration, conservation of momentum, force friction equation with F of F equals mu F of n, and kinematics equation. The frictional coefficient existing between the road surfaces and the tires of both the car and the tractor trailer. So we have F of F is equal to F of n, mu of the car. So the mu of the car is equal to 100 newtons divided by 130 newtons, and we get the mu of the car is equal to 0.769. And the mu of the truck is equal to 70% that of the mu of the car, so we get 0.70 times 0.769 is equal to mu of the truck is 0.538.
In step 2, we'll be determining the speed of each vehicle after the collision, starting with the car. At the car after the collision, force normal is equal to the force of gravity, and by rearranging these equations, we get that mass times acceleration is equal to mu times the force times normal force. By breaking each of these variables down, we get that acceleration is equal to mu times the acceleration of gravity. By rearranging this and plugging values in, we get that acceleration of the car is equal to 0.770 times negative 9.8 meters per second squared, which is equal to negative 7.546 meters per second squared. By using the change in x plus the final velocity and the acceleration that we got from the previous equation, we can plug this into a kinematics equation for velocity, where we see that the initial velocity of the car right after impact is 11.124 meters per second. Following the previous part where we solve for the velocity of the car, we will solve for the velocity of the truck. By using the same principles, we will put in the coefficient of friction times the gravity, where we solve for the acceleration of the truck, which is negative 5.282 meters per second squared. By using the change in x position times the final velocity and the acceleration we received from the equation earlier and plugging into a kinematics equation, we get that the initial velocity of the truck right after the collision is 10.780 meters per second. In step 3, we will be calculating the velocity of the vehicle before the collision by applying the law of conservation of momentum. The equation seen to the left is momentum is equal to mass times velocity, which is the law of conservation of momentum, as P initial is equal to P final. P sub Ix will be equal to momentum in the x direction before the collision, and P sub Iy is equal to momentum in the y direction before the collision. The initial momentum for the x direction will be P sub Ix is equal to V sub Ti times mass of truck times P sub Iy times velocity of the car times the mass of the car. For the equation, we'll be using momentum after the collision. We'll be using P sub Fx is equal to the velocity of the car final times cosine 33 times the mass of the car plus the velocity of the truck cosine 7 times the mass of the truck. And for the y direction, we'll be using momentum of y, or momentum sub y, is equal to velocity of the car, sine 33, mass of car, plus velocity of the truck, sine 7, times the mass of the truck. As momentum is equal during the beginning as it is in the final, we can break these equations down to velocity times mass equal to velocity times mass. As we manipulate variables around, we see that V velocity of the truck initial is equal to the velocity of the car final cosine 33 times the mass of the car plus the velocity of the truck final times the cosine of 7 times the mass of the truck, all divided by the mass of the truck, where we get the initial velocity of the truck is equal to 12.52 meters per second. Applying the same principle to the velocity of the car, or to solve the velocity of the car, we see that the velocity of the car is equal to the velocity of the car final times the sine 33 times the mass of the car plus the velocity of the truck final times sine 11 or times sine 7 times the mass of the truck, all divided by the mass of the car. Substituting values in for both the mass of the car, mass of the truck, and for the final velocity, we see that the car's initial velocity was 12.79 meters per second. So who's at fault? Let's let the jury and judge decide. The truck. The driver, Dr. Murrow, claimed to have been going 6.7 meters per second before the collision, but shown from our calculations, he was actually going 12.52 meters per second before the collision, going against what he said initially. The car. If the car had come to a complete stop, the velocity before the collision would have been 8.83 meters per second. However, because it had a velocity of 12.92 meters per second, it is evident that the car did not make a full stop, considering that the car had flashing red lights while the truck had flashing yellow. The final verdict. While both Dr. Murrow and Dr. Caffrey lied about their velocities before the collision and were going faster than they had initially claimed, the crash was caused by both drivers. However, according to the law, Dr. Caffrey was facing a flashing red light compared to Dr. Murrow, who was facing a flashing yellow light, making Dr. Caffrey more at fault for driving through the flashing yellow light as she was supposed to initially stop and look out.
The slideshow, calculations, and the video.
My name is Andrew Trinidad, and I help with the presentation and paper.
My name is Sophia, and I help with calculations and part of the paper.